Hi, in this video, I'll be showing you problem number 4 of chapter 12, section 6. Describe and sketch the surface 4x square plus y square equal to 4. So consider the equation 4x square plus y square equal to 4. So in a 3-variable problem, here one of the variables, namely variable z, is missing. So in a surface, if there is a missing variable, then that surface is a cylinder. And the axis of the cylinder, the rulings of the cylinder will be parallel to the axis of the missing variable, which will be z in this case. So z is the missing variable. So the surface is a cylinder. And what type of cylinder is this? So that gets determined by that equation 4x square plus y square equal to 4. So what type? So we are going to make horizontal traces, which means we are going to see what the intersection of the surface is along the plane z equal to a constant. If z is constant, that means it's a plane parallel to xy, the coordinate plane xy plane. It's a plane parallel to xy plane at a distance k. The k can be replaced by any value. K can be positive or negative or 0. So let's assume a generic value for k, and then we will see what happens to the equation 4x square plus y square equal to 4 along with z equal to k, or families of ellipses, because we can bring this 4x square plus y square equal to 4 to the standard elliptic form where the right hand side can be made to 1. So it is 4x square plus y square equal to 4. So if we divide throughout by 4, you get x square over 1 plus y square over 4 equal to 1, which is an ellipse on the xy plane, cutting the x-axis at plus 1 and minus 1, and cutting the y-axis at 2 and negative 2. So xy trace, or the trace parallel to the xy plane, is an ellipse. The rulings are parallel to the axis of the missing variable, which is the z-axis. The rulings are parallel to the z-axis. Now let's sketch this graph. So x, y, z axes are shown here. If we take a specific value for k, just for an example, k can be anything. If we take z equal to 0, then you will have an ellipse cutting the y-axis at 2 and cutting the x-axis at 1. So this is the xy plane itself, because this corresponds to z equal to 0. You can do that for any height. You can consider another z, namely z equal to 3 plane, which is horizontal plane at a height of 3. Then there you get another ellipse cutting the x-axis at 1 and y-axis at 2. Then you can also consider a plane down, horizontal plane, below the xy plane at a distance 4, z equal to negative 4. So we can consider at z equal to negative 4, and we'll get another ellipse like that. So cutting the x-axis at 1 and cutting the y-axis at 2. So these are all the ellipses, a family of ellipses. You will see lots of ellipses like this, so which make up a cylindrical shape. And if you consider the rulings which are shown in the graph, these rulings are parallel to the z-axis, which is the missing variable in the problem. So the graph is actually an elliptic cylinder. The surface is called an elliptic cylinder. So the top ones are all xy trays. These are all ellipses. So at all values of k is equal to k, these are ellipses, and this surface is called an elliptic cylinder because the base is ellipse and it's in cylindrical shape. Hope this video helps.